I think we are going to go ahead and start our next presentation. We know that Patrick and I'm Hemal, architect at Broadcom, and Patrick here, my colleague, is from Lenovo. We both are work group chair in DMTF of PMCI work group. So in this presentation, just a little bit of history. Platform management communication infrastructure standards that you hear quite a lot about, like MCTP, PLDM, and CSI, they have been around for 20 years. And we continue to get additional use cases, and we continue to enhance it, support more bindings, support more physical medium, have higher level protocols. So that our focus will be focusing on some of the advanced OCP use cases, and then take you through some of the enhancements we have done recently in PMCI standards. So with that, let me hand it to Patrick.
Thanks, Hemal. So just a quick disclaimer. Some of the information we're going to provide to you today is a work in progress within DMTF. So it is subject to some revisions and some changes as it goes through the process. So if you're ever interested in the latest information, you can always find that on the DMTF website. Hemal kind of mentioned a bit of what the agenda for today's talk will be, but it's going to be a bit of a background, just a real level set of what the PMCI infrastructure working group provides, and then we'll go into those enhanced use cases along with some of the actual next features, functions, bindings that are coming. So you'll see all that along with the call to action. All right, so let's get into some of the details of what the DMTF PMCI working group is and does. As Hemal mentioned, it's actually been around for now counting more in decades versus years. But first, DMTF creates manageability standards, and PMCI is a working group within DMTF, along with some other groups such as the Redfish Forum, SPDM working group as well. Really, the focus of PMCI is to provide communication standards for functional interfaces that are, quote, inside the box. Right? So these are the things that are going to interconnect devices traditionally from your management controller, typically implemented as, say, a BMC or other types of MCs, and then endpoints. Those could be, networking devices, storage controllers, storage devices, accelerators, et cetera. All that has some communication that wants to be done to collect information that is relevant, whether it's sensors or doing firmware updates or just getting logs. You'll see all of that. That's what PMCI does. DMTF's just released a new infographic trying to describe all of what DMTF does. I know it's small, it's tough to read, it's in the upper right corner, but it kind of shows from the hardware elements that are central to any sort of infrastructure and platform that DMTF is providing capability of management that extend beyond that with the security layer with SPDM, and then you get kind of the messaging and transport layers like MCTP, PLDM, and NCSI. That's circled in red. That's really what the focus of PMCI is going to be and what we're going to talk about today. Lower right, that's our stack. One of the things that I think we've seen so much growth and opportunity around these standards is they were structured in a way that allows it to be easily extendable. They're done with layers. We have a physical layer, think PCIe, USB, I2C, SMBus, I3C, et cetera. And we've built these transports, MCTP, and also the RBT transport as well in the past. That was allowed to be extended to multiple physical bindings at the lower layer. Above MCTP, you can actually attach many, many different messaging layers. Call it the upper layer. PLDM being one. There's also many other ones. Kind of tough to read the chart, but you'll see this on the DMTF and PMCI websites. But it really provides that extensible way, and we're seeing the continued growth of OCP platform components and some use cases that we'll talk about. So what are those OCP advanced use cases that we want to start looking at how we can address with manageability standards from PMCI? So as you can see, all of you are walking the floor and have been here at OCP Global Summit for the past few years, things are becoming far more complex. In particular, the scale, right? So scalability is happening at a very visual level, but internal, the scale is happening all the way down to sensors and things that we got to start collecting for things like telemetry. And that is really ramping up to a level that we're going to have to try to provide some new capabilities and features into the specifications to account for that scale. Things like debug and diagnostics, really important, right? When things we want to get some information on, right? how do we get those files? How do we get debug? How do we get things like configuring watchdog timers? How do we get bulk telemetry? Another key advanced use case here that we're seeing out of OCP. USB as a particular interface is becoming far more prevalent in terms of interconnecting all of this. We're seeing this added to a lot of different form factors, and where USB is ubiquitous in a lot of different ways, but it's also coming to a key management element within the platforms as well. And it's really emerging as an element that we can attach MCTP or even other bindings directly on top of USB and take advantage of that and then drive some of the capabilities to collect this data. We see hardware and modularity with DCMHS, the plug-and-play benefits around that. We've enhanced the FRU, kind of trying to modernize from a traditional IPMI-based FRU to now what is a new FRU format that's available from the PMCI working group. And things like enhancing, once again, OCP NIC, we've seen that. We've actually been talking about that for a number of years, Hemal and I, as we kind of really focused and started with some of the networking work with OCP. NIC 3.0 work that was done here, but we're seeing more and more opportunities, speeds, optics, and telemetry. And tools. There was some information in the Manageability Summit on Monday talking about tools. It's a really important factor as well. So let me give you an example of one of the features that we're kind of driving, and that's going to be around scalable sensors for PLDM. Now, you see this in Type 2. It's known as DSP 248. That's our PLDM monitoring and control specification. But there are additional provisioning that's needed for things like telemetry and monitoring. And these devices are starting to get quite large in terms of how many sensors they can have. And when you're reading tens, hundreds, individual sensors, it's a lot of data that you're trying to move around. So we got to create a way to have a scalable model, something that will start addressing the scale that we're seeing here at OCP, and how to approach that from PLDM layer. So, scalability with what's going to be known as cloned PDR. So a quick refresher, a PDR is a platform descriptor record. It's usually a way to describe something in a device, in a platform, and PLDM can basically abstract that into a PDR. You can have any PDR to describe a lot of different things. It could describe sensors, they can describe things like cores. And in a case where you have a 32-core CPU, today the specification would implement that in 32 different PDRs. And they are nearly identical PDRs. They vary in only basically kind of the index number that changes between each of those. But the cloned PDR is going to try to address that as we release the next generation of the spec, where now you have a base PDR and then a clone of that, so you have a total of 2 PDRs that represents all the remaining ones that are very similar in nature. Now, this is an example of 32 cores. Obviously, if you get into over 100 and more cores, you can imagine that simplification here is on a scale of like 99% in some of those cases, right? So the reduction is really key to kind of reduce the footprint, the memory, the transfer of data, and as we get more and more scale, the ability to have clone PDRs is going to be really helpful. In addition to the PDRs, there are entity association PDRs. In any system, there are associations that link either physical or logical elements together. And these also have a parent-child relationship within the PDR. So taking that same example of 32 cores in a CPU, you would have the CPU as a parent, and there would be 32 children that are kind of linked together. Well, the problem is that PDR only has 192 bytes today, and that's limited to 256 children. So we want to go beyond that, right? Obviously, the scale once again. So we're going to be also updating the entity association PDRs to only need 8 bytes, and that's going to allow us to now scale to 64,000 children in these associations. So things are coming. This is an example of how to match the OCP use cases that are becoming more prevalent. And just to give you another example of a couple other specs, there's a long list here. 4 of the 5 on this list are known as modeling white papers. So they're not actually the specification and the standard. The actual second one on the list, DSP 242, is a specification and standard. The other ones are white papers. They really talk about, there's a use case, for example, PLDM host SoC modeling or the upcoming PLDM bulk telemetry modeling. There's things that you want to do. So how do you take advantage of all these sensors, PDRs, and how do you actually describe the implementation? So the model is going to help give you an example through a white paper of how to do these functions, and these are going to be key. So we've got the SoC modeling. It's going to cover those SoC use cases. We've got compute, memory, PCIe, integrated NICs, all that could be within a contained SoC. And PLDM for file transfer, that was one of the more recent standards that was released. That actually just provides a way to push data in a format that transfers from one endpoint to the other. And things like bulk telemetry, crash log modeling, those are going to use the file transfer methods. So, but the model is going to describe how best to approach it, drive some commonality, and interoperability is really the key. So look for all these specs coming. That's a little bit of background on some of the next generation PLDM specs. Hemal's going to take it from here and kind of go into some more of the bindings that we're going to talk about. Hemal?
Thanks, Patrick. As you can see, now we go to a little bit lower layer. What we have seen is we have defined sideband interfaces, management interfaces in DMTF for a while. And USB, as you go to the systems where they are compact, you want a well-known standard which can support lower voltage as well as supports high speed. So we started looking at USB as a sideband interface for two different use cases that I'll go over. And then from OCP standpoint, you can see the OCP NIC 3.0 spec, OAM, all those, they already have USB signals out. So this kind of really helps, as well as with the SCM or UBB form factor. So it makes sense to leverage USB as a sideband interface and define the bindings on top of that. So that was the one recent work that we have done, MCTP or USB, which defines how do you transfer MCTP packets over USB using bulk data. And 1.0 version of that spec was already published, which supported up to USB 2.0. What it defines is for USB to be used for MCTP, it defines the descriptor structure as well as the transfer model. What we are working on is to further enhancing that in USB MCTP or USB 1.1 standard, which improves the transfer rate. So now you can have 3.x USB interface that can be supported with it. Bulk transfer also improves with the amount of transfer size that you can have there. So this is one area which, by having this binding now, you are leveraging USB as a sideband interface, and all the stack that Patrick was talking about, all the PLDM or upper layer which sits on top of MCTP can be used with the USB as a sideband interface. That being said, recently we have also started looking at, once we have USB, and then we have this RMII interface that's been used for both NCSI control and pass-through for a long time. As we look into future, this is something we can also have. Ethernet or USB model is very well defined. There's already support out there. We can leverage all those. And then layer on top of that both NCSI control and NCSI pass-through. What this will enable is to now have USB used for management traffic pass-through, and then you can leverage all the NCSI control communication that you have been using on top of RBT or MCTP can be now naturally or natively leveraged or using Ethernet or USB. So this is spec is under development. Currently, we have the proposals that are being discussed in DMTF. You are getting a preview of that here. If you have any feedback on any of this MCTP or USB or NCSI or Ethernet or USB, we really welcome that. So those are some USB related standard. Let me touch up on some of the other standards update. As you know, our host interface has been published for quite some time, and it was still leveraging the IPMI serial and KCS. So it's about time we really get to some modern interfaces. So that's where the 2.0 work went into. Other thing, we started getting people participating from the ACPI side saying, here, there is a well-defined communication mechanism, PCC. How about we define a binding of MCTP on top of that, which now allows the host and other firmware components or device to communicate using MCTP or PCC. So that was recently published. And then last year we had a presentation on fru data format. This is another legacy where we want to see industry start moving to more modern format we have defined in fru data. How you store it, how you retrieve it, and eventually this is one of the dream that you start getting rid of IPMI fru, which has been stale for a while. And this is the standard. And then we have also updated PLDM mechanism to retrieve that fru data format that we have defined. You can get a single fru item, or you can have the entire fru files being transferred using file transfer. So these are, again, some of the key enhancements we have made to our standards, which allows you to now start leveraging modern interfaces, modern transfer protocols. And finally, I want to touch on, we have this effort going on in DMTF for a while. People have been asking that you have all these PMCI tools. At beginning, it was hard to like, how do you define like interop for this? Because you are not going to have like a boards being done and SM bus or I2C. So then this tools task force we had came up with this proposal, and then now it's currently being actively developed, is you define this client service model, leverage the Python SCAPI framework, and then just use this standard TLS stack to communicate all your requests from the test client to the test service, and we will use, both will use the common library. So this way, there is a standard way they are communicating, and behind that test service, you can have device under test. So this will allow you to have, now you can test for interop of MCTP, PLDM, and other protocol stack that we were talking about. So this work is getting very close to being published. Our goal is to make it open source in 2026. And this will really allow industry to take it even step further by having these tools available for conformance and interop. Okay. So with that, to summarize, we went over PMCI. Patrick introduced the PMCI and then talked about some of the scalable sensor enhancement as well as PLDM model enhancement. I touched on USB interface as a sideband, MCTP and NCSI over that, and some other standards update. So our call to action here is, as you can see, this group has been working actively. More participation, more feedback, use cases will help us making this further advance it. There are different ways you can communicate to us. Join the work group. There's a feedback portal. There's a forum. You can use one or all of them. We welcome any feedback. So Patrick, if you have any.
No, I agree. We welcome the feedback. We've actually been getting more and more feedback, and come bring us the use cases, bring us the items that you're interested in, and our goal is just to continue to advance forward these manageability standards and focus on these opportunities here with OCP.
Okay. So I think we have, Jeff, time for some questions, right? Okay.
So maybe this is a use case, but for the scalable sensors, are you also going to define scalable entities? So my example is like a typical GPU has like dozens of regulators, right? They're all, in them is a set of sensors and they're all the same, right? Are we going to have a mechanism to scale those the same way we can scale the individual PDRs? Or can we have that?
Yeah, I think, again, the structure that's been done with that clone PDR is anything that you're describing at an entity or things that has a similar nature, you can describe through the clone PDR. So whether it's a regulator function, I use the example of a CPU with numbers of cores, right? So the goal is to try to take similar elements and be able to collapse that down through the clone PDR, so you can just basically have an index of however many you need with smaller memory footprints and smaller PDR records, and I think that will be extensible. It's not just for the cores, it's a structure that can describe any type of entity you want through PLDM.
Okay, cool.
And those proposals are out there as work in progress. Feel free to give us feedback on that. Any other question? It's like people are hungry. All right, thank you.